So again, I'm not Rob McDonald. I'm standing in. I'm Brandon Litherland here at NASA Langley. And as I said, we're going to get into some parameter linking and user parms. So why would you want to put links together in the first place? So essentially it's here so you can establish relationships
Brandon, you're on mute.
between the individual parameters. One second. There we go. I was muted in the Teams, but I was good online. But I'm set. Okay.
Sorry.
So you also may want to reparameterize your model. So maybe you don't want to size a wing by span or area. Maybe you want to use something like gross weight and wing loading. So you can also do things like embed the designer intent. So we cover this a little bit on the OpenVSP Ground School, but for everyone here, it's kind of nice to have a live demo where we play with some of these things. Another nice thing is to reduce the design space dimensionality. So if you only really want one or two or five or however many design variables to be the real driver of everything else, and you want all these other things to simply fall out from those, then you can link them together or code things up so that those are the only things that you really need to tweak, and it makes your design space that much smaller. And it also reduces the tendency for errors to occur when you are the one manipulating, say, 15 or 20 different things. You might make a mistake. And so you can also introduce new parameters or new kinds of physics by adding your own code into the model. So by default, there are predefined user variables or user parameters. So it's indexed from 0 all the way up to 15, so there's 16 of them predefined. And they have hard-coded IDs. So that's the special identifier that you can use kind of under the hood. They will always be called the same thing. So it doesn't matter what you do. If you insert multiple files, if you have multiple files, user 0 to user 15 always are called the exact same thing. You also have the ability, of course, to create your own. And you can make these have minimum max values, defaults, name them whatever you like, and you can control and organize them by the group, etc. So these parms have randomly generated IDs, and they'll map to different parameters if you, say, copy in from one to another. So the name of it might be very similar, but the ID that's underneath is going to be sorted out for you so that if you have a link associated to one file and then you drop that into another, it won't get destroyed in the process. All of the user-created parameters can be adjusted from the user parm GUI all in one spot. So in this case, you can see an example here. Each of these, just as a kind of preamble to some of the stuff we'll look at later, red indicates that it's linked or it's a driven component. Green indicates that it's the driver. So these have essentially been linked to parameters in the model, but it's reporting out things that you told it you care about. And so all of those can be found here under the adjust part of this. So let's move on a little bit to talk about just the straight linear linking that's built into OpenVSP. And the key here is that it's whatever variable A is times a scale plus some offset is equal to the B variable. So we make this reasonably intuitive to set up. You've got your parameter chooser, and again, you can go through and pick each one of these from a drop-down, or you can drag and drop, which is kind of the preferred method. And then you define what the relationship is here. You may also put constraints into this, and you can add, delete, clear all the links, and you can also sort by, say, the A variable or the B variable, because this list can get very long depending on how complicated this is. And of course, down here, we've got the new attributes feature. So any of these links that we've established have their own attributes, so you can create a description as to what this link is doing or what it's for, or have it report out some other value. And all of that capability is set up here in the linking GUI. Advanced linking takes this a little bit farther. So this is when things become nonlinear or code-based. You have all of your VSP parameters that you want as inputs, so you map those to an input variable. You've got some code that will run. It will produce whatever output variables that you've defined, and then those are subsequently mapped to other OpenVSP parameters. And so it's just a step-by-step process of relating one thing to another based on some code that you define. And we'll go into that a little bit more. So to manage the advanced parameter links, all of that is up here. You can change the name, add, delete all of them, and those are organized here. And then, of course, you've got your parm picker. So you can choose things by container, or you can drag and drop. The name is set here. There's also an auto naming convention. So the other day when M4 was talking about this with some of the other attributes, we've got auto where we can just say container, group, alias, the parm name, whatever, and it will automatically make this for you. The variables themselves are managed as input parameters and output parameters. So here you can see the variable names are here on the left, and then it shows you the mapping to what parameter that belongs to. So in this case, that's that disk loading we saw earlier, that group, and it's in the user parm container. The output here is simply diameter. So this is something that's going into a disk design group. So it's sizing a disk. So here is your bit of code. And really this is just math with semicolons. You can see that they've declared a double here. It's the disk area, gross weight disk loading, and then the diameter area. The diameter of it is simply follows this equation. Boom, you're done. You click compile, and if anything goes wrong, it'll pop up a warning message. This will be red if it's inactive. But once you click this, it's gray. It means it's active. If for whatever reason you have this and you want to save it, you can file write and file read, so that if you have, say, a common block of advanced link scripting that you would like to use, you can save that and then read it in later. Save yourself tons and tons of time. As we mentioned, the variable naming here is all set up according to input and output. You do have automatic variable names, which we'll demonstrate again here in a little bit. But what's really nice is you can drag and drop the targets. So if you type in a variable name and you want something that is now an input variable, you simply drag from that variable over to, say, input parms, and it creates the new input variable with that assignment without having to go through and pick everything. So that'll save yourself a whole lot of time. It's very, very handy. There's also the ability here to change the variable order. Now again, if your model becomes very complex, you've got a lot of these links, and you have variables upon variables, you can sort them by the variable name itself, so it will sort it out here. Or you can sort it by container, group, or parm. Had that backwards there, container, group, parm. And so in that case, if you have something that's, say, in a similar container or in a similar group, you can sort those all out and say, now here are all of the variables that I have from this specific group in this container that are linked here, and you can do the same thing over here on the output side. That gives you a handy way to visualize where all this stuff lives. And if you don't like the order, of course, you can always just pick one and slide it up and down, all the way to the bottom, all the way to the top. A fairly recent addition, and I mean, it could have been a year or two because time's gotten kind of fuzzy over the years here, but you can now rename these variables. And so when you click on these and you choose to rename it, say if you decided that diameter wasn't good enough, what you really meant was rotor diameter or something else, or if the name was too long and you wanted to make it something shorter, this dialog box will come up and you can choose to either rename the variable only, or it'll run a search and replace in your code box, and it will rename and it will update the code. So anytime it finds that particular variable, it replaces it. And so you don't have to go through and find everywhere in your advanced link where you happen to call or point to this specific thing. It will do that for you. So very versatile, very handy tool to kind of improve quality of life. And if you change your mind, you can click cancel. It will close the dialog box. Nothing happens. So trying to make it very user-friendly to everybody out there. Also, if you have a variable that's created or renamed and something like that already exists, it will recommend a unique variant. So it says, For example, if you tried to make a new variable called disk loading and it was already there, it would say, oh, would you like to use _1 instead? It will let you go ahead and create that. So it drops it in. And then if you want to go in and say, well, here's my variable, the mapping is correct, but I want to change the name to something else, you can, again, go through that process of renaming the variable, or you can hit cancel and fix it yourself. But the option is there. It will flag this and warn you, hey, you're about to do something goofy. You need to fix it. Another handy feature here is that you can select these variables either and copy them to the clipboard, and then you can paste them down into the code. So in this case, you can use, Control C or Alt C, Option C, whatever the Mac equivalent of that button is, and copy the name, and then down here in your code, you can just paste it. And that's a handy way, instead of coming in, and if you're worried about having a really long variable name and having to type that exactly right every time down there in your script, you can copy and paste and kind of save yourself the headache. So again, a lot of quality of life features have been added to advanced parameter links over the years here. So a bit about advanced link code. So it is based in AngelScript. It's a C++ or C like scripting language. Like I said, it's basically math with semicolons, but it's kind of, I won't say it's completely unconstrained, but you can do silly things. So if you, for whatever reason, decide to put yourself into an infinite loop, on your head be it. But as Rob pointed out the other day when he was speaking about, the community support side of this, there is this help button here. And so clicking on that help button in Advanced Parameter Leaks will bring you to that HTML help file, and it walks you through all of the things that you can do, the math, the operators, all of that stuff. It walks you through everything about advanced linking. So that's an excellent resource. If you're just getting into this, by all means, go in and look at that help page and see how things shake out and what you can do with it. It's a really good place to start. Some behind the scenes changes. So for example, let's say that you went from something like an ellipse to a rounded rectangle. It used to be that if you had a parameter linked to that, it would destroy the parms because that ID no longer exists. It didn't know what to do with it. Now you can change those, and it doesn't necessarily destroy the parms themselves. It might throw a warning and refuse to compile if things have messed up a little bit. But let's say if your rounded rectangle radius is no longer a part of that, or let's say if you went from a certain cross section that has a certain group or container type, and then you went to rounded rectangle the other way, those parms could be called something else, or they may change entirely. The links could break. Well, there's a bit of a mapping there that's trying to save a bit of that headache, as well as parent-child relationships without doing a copy and paste component, so that also doesn't destroy the parms and thereby your links. The cross-section aliases that you have now give context to the model. So instead of somewhere along your fuselage, let's say you have cross-section 4, instead it's called firewall or bulkhead. So now you can have that cross-section alias either part of your variable name, it's going to be within the parm group, or you can use that auto naming convention, and now it's firewall width or something. So it makes things a little bit more human friendly and human readable, instead of you trying to keep track of in your head where all this stuff is supposed to map. So I spent about 15 minutes or so going through that. We've got a few demos queued up, and I'll switch over to that. I'm not seeing any questions in the chat just yet, but while I'm switching, the little bit of delay into the YouTube stream might allow for that. But I'll exit out of this and bring up OpenVSP, and we'll do a couple of demos. So I think, let's try this version. Okay. So one thing that we can do fairly quickly is we'll just add our regular default wing here, and then I'm going to add a second one, and we're just gonna say shift this aft a little bit and move it up, so we have two copies. And we'll just do a very quick demonstration of what it is to link one or another. So if we go into our model, we can go to links, advanced links, user parms are down here. In this case, we're just going to bring up links. And just for fun, let's go into the section of the second wing. And I'm going to flip the root and tip chord here. So all I'm really going to do, I want my tip chord. Oh, that was a handy thing. I guess we haven't demonstrated for everyone. So if you click on one of these Parm buttons, it brings up this window. So it tells you the info about what that parameter is. It tells you the current value, min, max, a little description as to what it is. And then here it tells you anything that it's linked to and anything that's linked from it, as well as any advanced link input or output variables that happen to be there. So if we didn't go over that before, I apologize. That's one of those handy features in OpenVSP that people find very useful. So here, I want my tip chord of the second wing to be the driven component. So again, I'm dragging. You can see I've got my little paste clipboard button here. I'm going to let go. And now we have tip chord for cross-section 1. Great. So I want the root chord of this first wing to be in there. And notice that, again, OpenVSP's policy here is, don't make any changes that aren't intended. So it went in and said, okay, well, you have these two. They're currently an offset of -3 based on what we said. So nothing went in and changed, even though I haven't added a link yet. If I want to force that to do something different, I can turn off that. And let's just say we want them to be equal. So I'm going to scale them to 1, or I could just set the offset to 0. Same difference. So one thing I could do is set lower and upper bounds. So if I wanted to set the lower to something like, say, 0.5, let's set the upper to 10. Why not? And now I'm going to add that link. Okay? So here we've got one of our links pulled up. Again, root chord is now green. That means that it's a driving component. And if I come here into links, sure enough, here we go, and it's linked out to the tip chord of this second wing. Good deal. So now I can shrink it down, but again, I can shrink this down to 0 if I want, but my minimum or my lower limit is being applied. I can make it bigger, 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 and it stops at 10. So all of that is behaving just like we expect it to. So anywhere in your model, if you want copies of multiple things to follow along, you can simply link all of the parameters to be together. Now, that's going to make a lot of links, but let's do a quick demo just to see if we wanted to make a regular old copy. I'm going to delete all of these. Under the wing, let's say, for example, I want everything about cross-section 1 to match cross-section 1. So in this case, scale is 1. I'm going to turn these limits off, and I'm going to link all. Now, everything in cross-section 1 was suddenly activated. So if I come in here and I start playing around with span, it's manipulating it on the other side. Everything here is also connected. So that's a really fast way to just kind of dump a bunch of links into your model. And again, it makes a lot down here. Now, if you didn't intend to link every single one of these, you kind of have to go through and delete the individual links, or you can sort by and you can clean it up later. But that is something that you can do if you happen to have a certain geometry and you have different versions of it. You're absolutely welcome to just link all in whatever group that you happen to be in, and it will automatically set these up for you, however you've defined them. But, use with caution. You can get yourself into a little bit of trouble if one of these is different than you intended. Let's see, I've got about 10 more minutes. So in that case, let's clear this out. And we're going to make a new model. In fact, I can probably just go ahead and open one of our examples to save ourselves some time. So what I'd like to do, here we go, our wing sizing example. So here we have a wing And under our model, we come to our user parameters, and I've got two new variables that I created. So I gave it a name. I chose that it was a double type, and so I gave it a min and a max, and I created. So just as a quick demo as to what that looks like, let's do this as, say, a dummy variable. We can change the group and call this one test. Set the minimum to say 0. And instead of a double, let's say this is an integer. So we'll create that. So under the adjust, notice that we've got them broken out by group. The design group is our wing loading variable here. Weight is our fixed gross weight. In this dummy variable, you can see that it's an integer. It's just counting as I'm sliding things around. It won't let it be anything except an integer. Now in the wing itself, you can see that I've got this plan form area linked. And I've done this in an advanced link in Wing Sizer. So let's have a look at that. So under Model, we'll pull up Advanced Link. Here's our Wing Sizer. Again, our gross weight and our wing loading are input variables. So if I delete that, it's going to cause some problems, but I can always just add it right back in. And then here, this total area parameter for that wing is my output variable. And again, it's just one line of math, gross weight divided by wing loading, size my area. Cool. So all that's doing now is if I come in here and say, instead of a 10,000 pound aircraft, I want 5,000. And it shrinks my wing. If I want to play around with my wing loading and drop that down to something like 20, okay. And so it's doing everything that you just told it to do. No real surprises there. So let's delete this wing loading variable. So there's no input parm called gross weight. This isn't linked to anything anymore. Sliding it around does nothing. So over here, you can see, aha, no matching symbol wing loading. It said, I can't compile, this is broken. So what we'll do instead is we're going to do our wing loading. And like we said, we're going to grab this and we're going to drag it right over here to our input parms. Now that matches. We're going to compile again. Great. Everything is linked up and we're good to go. So maybe GW is confusing, or maybe I want to pass this on. Let's rename this. So I'm just going to call this gross weight. So instead of just renaming this, I'm going to rename and update in the code. It updated here, and it updated down here. And again, everything is fine. So all of that is still working just like we expect it to. Another way that I like to use for a fun demo of links and advanced links and tying things together is this can get kind of squirrely. So there's not really a limit to kind of these stupid OpenVSP tricks that Brandon likes to do every once in a while, and I just kind of get a kick out of it. So in this case, I have a whole bunch of nested hinges with a bunch of pipes connected to them. So I've made a weird little hexagon here. And so let's pretend that you had some type of articulated linkage that you wanted to behave some certain kinematics or whatever. But really, you only wanted it to either be stowed or deployed or some fraction in between. You wanted to be able to control all this stuff. Well, from here, I have my hinge fraction, and I can make this deploy or roll up on itself with a single parameter. And so all of those are linked to this variable. And so I'm telling it to go through a certain range, and really all of that is just simple linear linking. I'm telling it that I want it to rotate by some fraction of this 0 to 1. And so I'm saying, here is how far I want you to rotate. If you're at 1, you rotate 60 degrees. If you're at 0, at 0. So all that is linking each of these hinge fractions to each of these. And it makes it very, very simple to do articulated motion in something like OpenVSP, where otherwise you might have to put together a series of blanks or hinges or script this up or do something kind of silly and cumbersome to try and make this work. But user parameters and links makes it very straightforward and very easy. So I think, I'm trying to remember if there was another demo here that I wanted to show. Oh, yes. So there's another one here. So this is an interesting little compound folded wing. So here we've got our hinges, and so this is something kind of like a Grumman hinge. So if you want to stow a wing for packing on, say, the deck of an aircraft carrier or in a hangar or something like that, and you need these wings to be articulated, well now, as we kind of showed with the hinge another time, you can make these stow and deploy however you need to. So I'm going to reset the range here. I'm going to come all the way back and come down. So now I can go to 0. We can straighten that one section out. And again, this hinge is just oriented over here. It's kind of in the ballpark of the quarter cord. And it's, you know, in this case, it's using the transforms. And we've got a 45 and a 45. And so it rotates about that. And again, here, we're not really linking anything. We're just using hinges cleverly. But you could very feasibly, again, apply a link to this and say, well, for each one of these, I want it to just unfold all together. So you either have stowed or deployed. You can certainly connect this up. Another use case that, personally, I've never done this. It'd be a heck of a lot of time, and it's not something that I really need. But if you wanted to size something like a jet engine, and you wanted to use area ratios and your pressures and temperatures and stuff like that, you know, going from station to station, you wanted to code all that up, you are absolutely welcome to link the areas of those cross sections, and you can code all that up. So now you can size an engine in OpenVSP based on your station definitions. And so if you wanted, you know, your pressure ratio to drive the entire thing, you can absolutely do that. So I've got a couple of minutes here before we move on into the next presentation, but just a few demonstrations of how links, advanced links, user parms can really change the way that you interact with a model in OpenVSP, and the things that you can get away with, the way that you can make a model much more intuitive. I mean, OpenVSP is very user-friendly. It has a lot of parameters that just kind of make sense to aircraft designers. But if you want to drive it using other things, or if you want to use, say, user parameters as a translation layer between some sizing code, have it drive one thing in OpenVSP and have that linked to all of your other relevant geometries, you can absolutely do that. So if anybody has any questions while we get swapped over, I'm happy to answer them. But otherwise, I'll go ahead and close this stuff up and we can move on to the next talk.